In this video, we're going to explore the difference between the population regression model and the sample regression model. Let's begin with the population regression model. First, let's define what population means. A population is the full set of units you care about for a particular question. For example, if our question is about UK house sales in 2024, the population is all house sales in the UK during 2024. Because the question is explicitly limited to that year and country, we don't need transactions from other years or places for this population. It is important to define the population frame for our research question. The population equals all units contained in that particular frame. Now, suppose we obtain data for the entire population. The population regression describes how the expected value, or average value, of the dependent variable y depends on the independent variable x across the entire population. Mathematically, we write the population regression model as yi equals beta 0 plus beta 1 times xi plus ui. If we take the conditional expectation given xi on the first part of the model, we obtain the population regression function. The expected value of yi conditional on xi equals to beta 0 plus beta 1 times xi. This describes the true relationship between x and y across the entire population. Here, beta 0 and beta 1 are the true parameters we are interested in. Ui is the error term, defined as the difference between yi and its conditional mean. Ui equals yi minus the expected value of yi's conditional on xi. Note that an important concept here is that, by construction, the error term has zero conditional mean. Let's derive explicitly why this is the case. Recall that the error term means the difference between y and the expected value of y, given x. We can then take expectation given x on both sides, and using linearity, we can see that what we are left with is 0. Hence, the error term has zero conditional mean. Now, let's dive into what beta 1 means. Since we are interested in what y would be given x, we take the conditional expectation of our population regression model. Now, suppose x is continuous, we can take the derivative with respect to x, which equals to beta 1. What this means is that the conditional mean of y changes by beta 1 units when x increases by 1 unit. Now, let's move on to the sample regression model. In practice, we almost never observe the entire population. What we usually obtain is a sample, a subset of the population. Suppose we draw n observations from the population. These are actual observed data. We use the sample to estimate the unknown population parameters, beta 0 and beta 1. Because we only observe a sample, our estimates vary with the sample we draw. Hence, we call them estimates. We will discuss how to compute these estimates in detail in later videos. Using our sample data, we write the estimated regression equation as y hat I equals beta hat 0 plus beta hat 1 times xi plus u hat I. The hats indicate that these are estimates, not the true population parameters. Here is what each term means. Beta hat 0 is the estimated intercept, our estimate of the population parameter, beta 0. Similarly, beta hat 1 is the estimated slope, our estimate of the population parameter, beta 1. U hat I is the residual. It is the estimated error using sample data, measuring how far the data point sits above or below the estimated regression line. It is the sample counterpart of the unobserved population error, UI. To summarize, the population regression line represents the true conditional mean relationship between y and x in the entire population. The sample regression line is our best estimate of that relationship, based on the data we actually observe. Understanding this distinction is fundamental because econometrics is about using sample data to learn about population relationships. Once we can estimate these coefficients, we can move from theory to evidence and start answering real-world economic questions.